Thank you, co-chairpersons. The Young Specialist Forum is a unique initiative of the GMA to inspire careers of its blooming young specialists. Next up, we have the Young Specialist Forum winners presentation. To chair the session, I cordially invite the co-chairpersons, Professor H.M.M. Herath, Professor in Medicine, Faculty of Medicine, University of Ruhuna, and Dr. Ganaka Senaratna, Consultant Physician, Teaching Hospital, Karapitiya, to the head table.
Good morning to all of you. The session that we are chairing is dedicated for the winner of the Young Specialist Forum 2021. This will be delivered by Dr. Harindu Ranga Kankanamheva. He is one of the senior registrar in medicine attached to the Teaching Hospital Karapitiya. The topic of the presentation is stethoscope of the 21st century. Are you ready for the new era in medicine? So let's listen to the presentation.
This is Google, undoubtedly the most popular search engine. It guesses what you intended to search as soon as you type the first couple of letters. Google Maps will find you the fastest route to reach your destination, considering real-time traffic. Social media platforms will identify you and tag you as soon as you upload photos. Luxury of self-driving and parking cars are already available in developed countries. So have you ever wondered how all this became a reality? The intellectual power behind all this. Ladies and gentlemen, this is artificial intelligence. Good morning, everyone. My name is Tarindu. I'm a senior registrar in medicine. Today, I'll take you through this amazing technology as it is evolving to become the digital intellectual companion for us, the doctors. So this is artificial intelligence in medicine. Along the way, I will introduce you to this term, artificial intelligence. How this technology will be applied to the field of medicine. And the potential this technology holds to transform global health in the future. And finally, some of the limitations of this technology. The term artificial intelligence was first coined in 1956 by John McCarthy. So what is it? Basically, it means machines mimicking cognitive functions of humans. What are the cognitive functions that we have? Learning as well as decision making. So in other words, we can say artificial intelligence is the use of computers for automated decision making to perform tasks that normally require human intelligence. So before moving on and learn this new technology, let's focus on traditional programming. So as you can see in this diagram below, in traditional programming, we have an algorithm which is manually set, manually made by a programmer. So when we enter data, this program has the capability of analyzing that data and come up with the results. For an example, if we want to differentiate apples from cherries, in simple terms, we can identify a variable such as weight. If the weight is more than a specific value, it's an apple. If it is less than that, it's a cherry. Or else we can use diameter. If the diameter is more than specific value, it's an apple. If less than that, it's a cherry. So let's look at this example. So as you can see, there are series of photos. In some photos, there are puppies. In others, there are muffins. What if we want the computer to correctly differentiate and identify muffins from puppies? Using traditional programming to do that, we might have to, probably it's an impossible task to manually set an algorithm with such a vast number of variables to correctly tell the computer to identify in between muffins from puppies. So this is where this new technology, machine learning, comes in. So it is a technique by which a computer can learn from data without using a complex set of different rules like in traditional programming. Look at this diagram. Here, first in this technology, there's a learning algorithm. Unlike in traditional programming, there's another algorithm which is called learning algorithm. This algorithm is fed with vast amount of data and expected results. So this learning algorithm itself will come up with a model or new algorithm which has the capability of analyzing that data and come up with the expected results. So when this new model applied to new data, then it has the capacity, or it can correctly analyze data and come up with results. I'll further explain this with an example relevant to medicine. So you can see there are X-rays. Some are healthy, some are fractured. So we feed a learning algorithm with large amount of healthy as well as fractured hands, X-rays of the hands. So this algorithm will come up with a model on its own. When we feed this new model, new algorithm with new data and new X-ray of the hand, this model has the ability to correctly identify healthy X-ray hands from fractured ones, and it will identify where the fracture is. Let's move on to our next part of the journey, where we will look at the applications of this technology in medicine. One such application is online consultations. In United Kingdom based company, Babylon Health made an app with AI driven technology which has the capability of doing online consultation. So through this app, patients can report symptoms and it will automatically analyze these symptoms and it will offer the patient with relevant course of action. This app also gives the opportunity for the user with greater access to their own health data. So this is one such application. Next, health assistance. Sensei developed Molly. Molly is a virtual nurse. It's an AI-driven virtual nurse where the patient can monitor their own health with customized follow-up care. Medication management is another aspect where we can use AI technology. Example is IQ app. So this is an AI-driven compliance monitor where it uses smartphone's camera to detect real-time ingestion of the tablet. So we can use this app for diseases with public health concerns, such as tuberculosis. So we can monitor the compliance of the patient. Even participants in clinical trials to make sure that the patient is adhering to their medications. One important aspect where AI might practically applied in medicine is triage. AI-based algorithms accurately predicted the need for critical care of patients in emergency departments. So they outperform the conventional triage tools that we use and early warning scores. There was another AI-based algorithm accurately predicting the septic shock at initial triage. So it significantly outperformed clinical scores in screening septic shock at emergency department triage. So how this AI technology can be applied to diagnostics? This is one such application, deep learning based automatic detection. So this app has the capacity, the capability of automatically detecting malignant pulmonary nodules on chest radiographs. They have shown that this app could outperform physicians in nodule detection for malignant pulmonary nodules on chest radiographs. When used as a second reader, it enhanced physicians' performance. This is one example where this app has detected a nodule. So in the X-ray, you can see there's a faintly visible mass just behind the cardiac shadow, which was later confirmed with CT chest. This is how the app detected it. This nodule was detected by only 7 observers out of 80, unlike the app. Another application is AI-guided ultrasound software. This software allows doctors to perform cardiac ultrasound without specialized training. So it gives you real-time guidance how to handle the transducer. So it acts as a co-pilot for performing ultrasound scan for optimized imaging. Another application would be designing treatment plans. IBM Watson is one example. It gives evidence-based treatment options for oncologists. IBM Watson is going to combine patients' data with clinical expertise and research papers, and it will suggest promising treatment plans for patients with cancer. Drug creation is another field where this technology is applied. Atomwise created a new tool with AI which can discover drugs. So this AI will root out treatments from a database of molecular structures. One example drugs would be 2 drugs predicted by this AI technology had the capability of significantly reducing Ebola infectivity. So as you can see, there are a series of applications of this technology in healthcare. So let's see how this technology will transform global health in the future. First, we'll focus on key issues in global health. What are the key issues in global health? One is inadequate access to healthcare, inconsistent quality of care, shortage of well-trained healthcare workers, inadequate access to rapidly changing management standards. So artificial intelligence would be the answer in the future for all these questions. Before implementing this technology, we might have to face key challenges. What are they? One thing is reliability and availability of data. As I explained earlier, AI systems are trained with large volumes of data. So the quality of output will reflect the quality of input. So we need to train these algorithms with quality data. And we need to locally validate these algorithms by locally available data. So we need local, digital, quality data to train these algorithms. These tools need right set of practitioners. So as doctors and healthcare workers, we need familiarity with these AI tools. And we need to have the ability to assess the validity of these tools. That will only set proper implementation of these new technologies. And there's a common fear in healthcare workers that AI might replace them. So we need to address these misconceptions if we want to implement this new technology. Another challenge would be health systems lacking the capacity to regulate this technology. As we know, there is inadequate regulatory capacity even for traditional technologies. So AI-driven systems will create more complex regulatory challenges in the future. Finally, we'll move on to limitations of this technology. One limitation is unexplainability of AI models. So there are millions of learned parameters determining the output of AI decisions, which is created by learning algorithm itself. So even the developer might not understand how it draw conclusions. So this unexplainability will affect the trust by patients as well as medical professionals. Other problem is privacy, confidentiality, and data security, because AI needs access to medical records. They have shown that even data is anonymized, individual profiles might be traced back. So privacy is a problem. Other thing is biased AI. Example is this US criminal justice system using an AI to predict tendency of a convicted criminal to reoffend. This AI predicted disproportionately high probability of black people committing future crimes. This might be due to poor quality data used to train these algorithms. Another example is Amazon HR department using an AI to sort out best job applications. They have found that this smart algorithm favoring men. Another limitation is diagnostic errors. Boeing Max airplane crash is an example. So this is a faulty machine-driven decision overriding actions of highly trained pilots, leading to this disaster. So we have to keep in mind there is greater potential to cause large-scale harm with these technologies. So to conclude, AI is a promising technology which we might be able to use in everyday medical technology if policymakers make policies that favor adaptation, medical associations give clear guidance on implementing, and medical community accepting this technology as stethoscope of the 21st century. So, are you ready for the new era in medicine? Thank you.
Thank you, Dr. Tharindu Eranga Kananka Heva, Senior Registrar in Internal Medicine, for your excellent and eye-opening lecture, which was actually the winning presentation at YSF 2021. I would like to make this opportunity to thank all the judges of YSF 2021. GMA President and the Council would like to extend profound thanks to these judges. They are Professor Tilak Veeraratne, Professor Sampath Gunawardena, Dr. Arash Disanayaka, Dr. Krishant Jayasekara, Dr. Aruna De Silva, and Ganaka Senaratne. World Medical Association wish all the very best for Dr. Tharindu and all the senior trainees in Teaching Hospital Karapitiya for future endeavors and their professional development. Thank you very much.